Today I'm going to run through start to finish how to electroform something using the Cu Electroforming kit sold by Enchanted Leaves. As a disclaimer, I am going to omit quite a bit of information on the process just to make this video a little bit shorter. However, all of that information is in the step-by-step tutorial booklet included with every kit. For this project, I'll be doing an acorn, which does require a few extra steps and some special care. So if it's your first time ever using our kit, then I would highly recommend doing something plastic or glass. Those materials are good stepping stones to give you a little experience before tackling more complicated projects. For these dried acorns, the cap can be quite loose on top of them. Also, there's a little bit of a gap between the cap and the actual nut. So I like to separate the two and then use a glue to kind of both adhere the cap to the nut and fill that gap a little bit so that it just looks a little nicer in the end result. E6000 is a good choice for this because it has good body and a little bit of give to it once it's cured. It's not as brittle as super glue. With enough glue in there, you'll see when I put the cap back on, that glue kind of fills the gap, makes it look a little nicer. I like to use these little spring clips for just about everything. They're a really good jig to let glue dry and hold things, as you'll see later. Alright, it's been a little while, definitely not long enough for the E6000 to fully cure, but it is set up enough that I can do the next step. I'm going to attach a brass jump ring to the acorn so that I can hang it from a chain later. Now it's very important that you use solid brass jump rings. A lot of jump rings you find online are brass plated steel or iron. Those are not recommended as steel and iron can contaminate electroforming chemistry. For jump rings, I prefer to use super glue gel because it dries much quicker and you'll have to be holding the jump ring while it cures. After it sets up enough for the jump ring to be freestanding, I like to go in with the back end of a paintbrush and just smooth out the super glue gel a little bit, make it look a little nicer instead of a big blob. An important note here is that the electroformed copper layer is what's going to ultimately bond the jump ring to the acorn and give it structural integrity. The glue is merely to just hold it in place in all the intermediate steps that we're about to do. Once the glues have set, I like to use one of these spring clips and grab the edge of the jump ring like this. That way when I paint it and then I set it down on a surface to dry, the acorn's not touching the surface. Now, sealing is a particularly important step. My go-to is polyurethane. It's water-based, so it's very easy to paint on with a brush. As with all painting, whether you're painting a house or an acorn, you get better results if you paint several thin layers as opposed to one thick layer. So in this time-lapse, I'm painting 3 layers, letting each layer dry in between, and each layer is very thin. It's only maybe a drop of polyurethane on the surface of the acorn. Sealing is extremely important for organics. You're not just protecting your object from the electrochemistry, you're protecting the electrochemistry from the object. If I didn't seal this acorn, it would dissolve into the electrochemistry and contaminate it. Contamination can be irreversible, so you want to be meticulous when it comes to sealing things that could dissolve into the chemistry. The next step is conductive paint. I'm going to speed up this video segment too because it's very similar to the polyurethane sealant, with one notable exception. You'll see that there's a stick included with the kit. This is a reminder that you have to stir this water-based conductive paint very well. You'll see on the underside of this safety seal, there's this pasty, waxy type of material. Make sure to scrape that off and put that back in the jar. That's some of the conductive material and binders that are in the paint. Even more importantly, if I scrape out the bottom of this jar and lift it up to show you, you'll see an even larger deposit. It's extremely important to mix this into the paint so that it is a uniform consistency. And of course I'm looking at the camera and not what I'm doing, so I make a total mess here, but I'm sure you can do much better and keep things tidy if you just take your time with it. If the paint's been sitting for a long time, this will take a few minutes to mix. Same deal with the conductive paint. I'm just brushing on 3 separate layers with time for each layer to dry in between. Again, the thinner the better for these layers, so I'm probably using about a drop of paint per layer. You can see how a jar of paint this size could last for a very long time since we're using so little paint per project. Now we've gotten to the electroforming step. I want to point out something on this chemistry. I've already used this chemistry before to electroform some other things, so you'll see that there's some sediment at the bottom. This is normal after you've used the chemistry, and you'll see why later in the video. But for now, I just want to point that out because I'm going to be decanting the liquid off of the sediment very carefully here. I don't want to incorporate that sediment into the beaker. For the anode, I'll just unfurl this copper wire and place it into the chemistry. Then I'll get the MiniForm power supply ready by just unfurling the alligator clips and plugging in the USB-C wall adapter. Something to note here is that the lights I'm using for recording are extremely bright, so the screen on the MiniForm looks a little bit dim, but under normal lighting conditions, it's quite high contrast. Next, I'll cut off a small length of this copper wire so that I can feed it through the acorn loop and ultimately suspend it within the chemistry. Now, an acorn does provide an extra challenge because it's buoyant, so I put this little bend on the bottom of the suspension wire so that when the acorn floats upwards in the chemistry, it doesn't touch the suspension wire on the sides. I submerged the acorn to a good height within the chemistry and wrapped the suspension wire around the bamboo dowel. I also jammed the 2 spring clips against the side of the beaker to keep the dowel from rolling around. This is especially important if you have something that's buoyant and wants to float. On the MiniForm power supply, all I have to do is input the final current set point, which I estimate to be 0.20 for this acorn, and then press play. MiniForm will take care of everything else. It will monitor the copper deposit on your cathode and slowly ramp up the voltage and current over the course of minutes to hours, depending on how things progress. So here we are at approximately 1 hour. You'll notice that it's not shiny yet. Now that's completely normal. That's because it's a extremely thin layer of copper. At this point, it's essentially electroplated, so the superficial layer of copper is taking on the surface texture of the rough paint. Since we want to electroform, we just need to leave it in for much longer. Here it is at about 2.5 hours. You can see that the copper deposit has gained some thickness and shine. You could stop the process now, but for something that's going to be worn as jewelry ultimately, I want it to have much more structural integrity. The cool thing that differentiates electroplating chemistry and electroforming chemistry is that electroforming chemistry allows you to build as thick of a layer of metal as you want. You just leave it in longer. And here's the final result after about 12 hours of electroforming. Straight out of the tank, we have a shiny, malleable, durable copper deposit. The only minor flaw is on the loop here where the suspension wire made contact. That's because I left it unattended for about 8 hours. This is why in the tutorial booklet we recommend checking in every once in a while, every hour or so, and just jiggling the suspension wire a little bit. That'll prevent it from fusing to the loop and causing any surface irregularities like this. Now time for everybody's favorite step, cleanup. I use one of these coffee filters and put it in the funnel so that when I pour the chemistry back into the bottle, it gets all the big stuff. It won't get the super fine sediment, but as I showed earlier in the video, that settles out quite quickly and you can just decant the chemistry off of the surface of that sediment. While that's filtering, I can run through the last remaining items. Another anode. These do last a while, but we give you a couple to get started. A broader, flatter brush for bigger projects. Obviously some gloves. And this brightener solution is used as needed. You only put a few drops in the chemistry every once in a while. After many projects, you'll see that mirror finish start to slightly dull, and that's when you know you need to add a little bit more brightener. And lastly is a bit of Scotch-Brite. This is a little bit of a catch-all, kind of like those spring clips. It's a multi-purpose tool. I primarily use it for scuffing up extremely smooth surfaces that the polyurethane doesn't want to stick to. And yeah, that's it. I hope you enjoyed this run through of the Cu Electroforming kit sold by Enchanted Leaves. I hope it was helpful. Making the video is a little bit of a challenge for me. I definitely don't consider myself a video maker, and I know the microphone kind of sucks, sorry about that. But I hope you got some useful information and you can go on and make some really cool stuff.